So here's the problem that we're trying to solve. It's that the heat death sucks. That space is almost entirely a vacuum. Furthermore, it's a very cold vacuum. It's near absolute zero. There's no usable energy, and anything that does exist gets spread way further apart because the universe continues to expand. Uh, if only we had an energy source, it would be less miserable. So a possible megastructure that can do this is the Persson Collector. Um, so here's context, right? Number one, the vacuum isn't empty, right? Quantum fluctuations occur even in a vacuum. Theoretically, across unimaginably long periods, a stable atom of hydrogen can fluctuate into existence. And this can happen across the entirety of space anywhere. And assuming no proton decay, which is theoretical, this hydrogen atom will persist indefinitely, uh, which is kind of cool. We have like free hydrogen for no reason. Awesome. But this is so unimaginably rare that we would have to wait far longer than the universe has existed for a cubic meter to produce one atom of hydrogen. Um, Depending on the math that you use, the exponent starts to get a little ridiculous, like something like 10 to the 10th to the 40th power, which is just like an unimaginably big number. Still, free hydrogen is free hydrogen, even if it's a cosmic jackpot. So, what do we do with it? We can maybe collect it, right? We probably have free hydrogen, and if we collect enough of it, gravity will ignite a free star. However, hydrogen appears incredibly rarely, and any like atom that comes to exist immediately gets separated like by the expansion of the universe. So it doesn't naturally collect. However, if we counteract the expansion of the universe with gravity, just like our stars or galaxies do, collection becomes possible. So this is the first part of the Persson Collector. It's an accumulator. So we need something that is metastable across unimaginable time periods. We also need it to be hyperdense enough to locally counteract the expansion of the universe, so it's extremely dense, and not to turn into a black hole when we ignite a star around it. So some potential candidates for this exist, uh, but are kind of theoretical. Number one is quark stars, and number two is gravastars. But quark stars might exist, gravastars might not. Uh, we haven't really observed either. We might have observed quark stars, but if neither work, we'd need some advanced material engineering, perhaps quark level material science, which doesn't really exist right now, but could exist. So the second part is the shell's interface. Around the accumulator, we need a shell that is also metastable across unimaginable time periods. So it's kind of like a big Dyson sphere, except in the center you have a really, really heavy thing that pulls hydrogen towards it until you get a star. And then once your star happens to ignite, you have a giant collector array um, that absorbs the power and uses it for something. Uh, Ideally, its interface can collect energy from a star while containing as much of the baryonic matter as possible. So because hydrogen atoms are so rare, we don't really want them to get out, and the star turns hydrogen into other things, but like whatever it turns it into, whatever baryonic matter it turns into, we don't want it to get out. We want to recycle as much of it as possible, so we don't have to wait as long. Um, and ideally, the shell can reflect, all the energy, as much energy as possible, back into the star. So it just keeps it in a big ball. And so outside of the outer part of the shell, uh, there's some wiggle room here, right? It kind of depends on what far future technology supports, right? But this is maybe something like 0 Kelvin superconductors acting like lossless batteries, right? So I think lead becomes a superconductor at 0 Kelvin, uh, which conveniently is true of the heat death of the universe. So we're pretty darn close to 0 Kelvin, just like as an ambient environment. So that might be very feasible if we can make lead metastable or something like it. Maybe we can have some advanced self-replication or self-repair facilities. Wouldn't that be cool? Or perhaps some AI metastable post-human or simulated civilization. Right? There's some wiggle room here. But the only downside is it's got to sleep for unimaginable periods of time between stars. Anyway, so this is where we're at, right? So imagine some like really hyperdense mass that pulls any hydrogen in this empty vacuum towards it, and eventually you get enough hydrogen that a red dwarf appears, and that just burns like a normal star. We collect it with like solar panels, and then there's some stuff on top of it, right? That gets powered by it or stores the energy, right? Doesn't really matter. But this is kind of the important part. Um, so, yeah, we get hydrogen. Eventually, it ignites due to gravity. Uh, no lighter required. A red dwarf ignites. And the cool part about a red dwarf is that it's a very safe star that it burns super slow, it lasts a really long time, and it won't explode or turn into a black hole. So ideally, this is some crazy math I don't really know, but we can design the size of the shell and the mass of the accumulator and the empty space between the two so that only red dwarfs can form. Because if we get something like a black hole or a larger star, uh, a giant explosion in our shell would be kind of bad. So we harvest energy from the red dwarf, and maybe we use it for repair, self-replication, or we store it, right? Eventually, the red dwarf burns out. The cool thing is, 99% of its baryonic matter remains in the shell. So, of all the atoms that existed and kind of like got, converted into other things by the time the red dwarf dies, it's still in our giant box or our giant, sphere. Um, so the cool part about that is that even though it's not hydrogen, because of quantum tunneling, it will decay back into hydrogen over a really long time. Um, a really long time. But not as long as waiting for it to appear via quantum generation. So that means that between ignitions, we only have to replenish 1% of the lost hydrogen, which is pretty cool. Like it goes from waiting a extremely unimaginably long time to a slightly less extremely long time. Uh, Still very, very, very long time. Uh, so this is still really hard because it only works if there's a functional metastable material can be made and there's no proton decay. So proton decay is still up in the air. Some theories support it, some don't. We'll hand wave this until we get more evidence. But on the upside, our environment is a vacuum. It's energyless and cold, meaning materials last longer than otherwise. However, the real competitor is quantum tunneling. So basically, the same fluctuations that give us hydrogen like to pluck off um, particles in our really nice atoms and make them decay over unimaginably long time periods. And so, if we can make a material that resists this, uh, the collector is possible. It just needs to resist long enough to survive between ignitions, which might as well be indefinite considering how long that would be, but not infinitely long. Um, this may be impossible, but future material science might make this feasible. So, not totally useless, um, even though it's kind of just like a star every really, really long time. Uh, Making metastable materials is way more feasible than perpetual energy or zero point energy because there's no violation of the laws of physics as we understand them. This is technically something that like is permissible given what we know. It's just like, you know, not we don't know how to make it, right? Um, if Persson collectors can self-replicate and can be chained together in an array, even if it takes a long time, we could eventually expect to have unlimited power, hypothetically unlimited power. So that would be quite a few Persson collectors, but it would still, it could get to a point where it adds up. Though that's probably not likely, and I'm not sure how that would actually look. Uh, but even if it's dormant all the time, at least we have like some power in the heat death. That's a lot better than nothing. Uh, but not fantastic. So is this useful? It's a star's worth of free energy once every unimaginably long time period. It's not useful to you and me. We have plenty of other things to get energy from, and we will almost certainly be dead. We will be dead by the heat death of the universe. So it might be useful to some people far in the future, maybe our descendants, but that's a really, really long time ago. I won't assume too much. It's also fun to think about, I guess. This is kind of a curio. Um, I thought it was interesting enough to share. That's pretty much it. I'm not trying to claim that this is some amazing thing, but it's kind of fun. So, and maybe it sparks a better idea. It ignites a better idea. Um, but yeah, maybe this was entertaining, and maybe it's nonsense. But I hope you have a good day, and thanks for watching.